Hello, and welcome to my presentation. I am Nguyen, and I will be presenting about EM speakers today. First, we have to look at the anatomy of an EM speaker to understand the physics. Here is an image of a cross-sectional cut of an EM speaker, a standard one. At the base, we can see we have a heavy and stationary permanent magnet. And sitting directly inside the gap of that magnet is the voice coil, as you can see on the image here. It is simply a tightly wound copper wire, and the voice coil itself is physically attached to the cone, or the diaphragm, which is held in place by the spider. It is a flexible suspension system, and the spider keeps the coil perfectly centered inside the magnet while allowing it to move up and down freely. Next, we'll move on to the generation of the magnetic field inside an EM speaker. So you can see here, the speaker receives an analog audio and from an amplifier, and which is an alternating current or an AC current as we've studied in class. When this AC current flows up from the wires through the audio jack and into the solenoid, which here is the voice coil, it induces a magnetic field. And because the current is an alternating current, the flow of the electrons is constantly reversing. According to Faraday's law we studied in class, this means that the magnetic poles of our voice coil are continuously and constantly flipping back and forth between the north and the south pole hundreds of thousands of times per second, which makes the voice coil become a rapidly changing electromagnet. And we can also see the Lorentz force applied into the EM speakers. At the diagram here, the cross section, we can see the equation F equals I L times B, which is the Lorentz force equation we studied in class. The voice coil will sit inside the permanent magnet stationary magnetic field, the B field, signaled by the yellow arrows around here. And the blue symbols are the coil. Inside the coil shows the current I moving in and out of the page. And because our voice coil's polarity is rapidly flipping due to the AC signal, it is violently attracted to and repelled by the stationary permanent magnet. And this interaction generates a mechanical force, which is indicated by the green arrow labeled F, which push and pulls the voice coil and the attached speaker diaphragm. And in summary, an EM speaker is an incredibly efficient conversion system which takes electrical energy and convert it into magnetic energy with the voice coil. It uses the Lorentz force to create a mechanical movement and finally pushes the air, push and pull, to create an acoustic sound waves. And the frequency of the alternating current, or the AC current, dictates how fast the cone vibrates, which in turn determines our effect of having a higher pitch or lower pitch. And that amplitude of the current dictates also the magnitude of the Lorentz force, controlling how far the cone pushes and consequently the volume of the audio. And that is the end of my presentation. Thank you for listening.